about you?
Oh, doing good. It's
What's
doing
the time
good.
over there?
It's 1:30 in the morning.
Oh my God, 1:30 in the morning. Yeah.
Yeah, we must be really good friends.
Absolutely.
Uh,
Yes.
yeah.
I think you're ready, I think. So we'll start in, I think, in 5 minutes, 5 to 6 minutes.
Okay, that'd be great. I appreciate you inviting me. I'm excited about this presentation. I worked hard on it.
Yes,
A lot of research.
that's good.
Yeah.
So this year we are going to invite you, in India, and there are a lot of plans regarding the space cybersecurity. And you might know that India is growing in this sector actually.
You're growing tremendously. India is doing a great deal in this sector.
Yes, yes, absolutely.
Absolutely. Absolutely. There is a great deal happening with India in this.
Recently, India from the private sector, Skyroot, the name of the company is Skyroot. They launched the rocket named Vikram 1. 1.5 week ago, they did that and it successfully launched. This is the first private, company from India they launched. In first attempt, it's successful mission. They completed it successfully.
That's great.
And that's how, there are a lot of companies, governments taking a lot of initiatives, growing in this sector actually.
Yeah, that's great.
Yeah. And
Yeah.
as we know that we both talking about space, satellite, rocket propulsion to secure those aspects. That is
Yep.
that is very important. Yeah,
Yep. There will be a lot of economic opportunities for everyone in India as this takes off.
correct,
It's
correct.
going to be a big business opportunity.
Yes, absolutely. How things are going on at your end?
Oh, it's going good. Going good. Staying very busy. I'm
Hmm.
trying to working on learning AI now. Everyone has to do AI, right?
That
Yeah,
that is true.
yeah. Yeah,
Soaking all lakes.
that's right. Yeah. So, so just trying to learn AI like everyone else now. So,
Correct. It's boom in the market actually, and that it's very simple. Uh, it makes simple task actually. If you doing some analytics, it's really great to have this AI to process those analytic work. And I
yeah.
believe that space technology is also moving in that direction using
Oh,
AI
absolutely.
and yeah.
Yep. Yes, it is.
I think so. They are doing from long time, not this time actually.
Yep.
Anything you are working on, something new in space?
I haven't, I've got some things I'm interested in researching. I don't have a new space presentation yet.
Hmm.
I got, I've been working on some interesting topics in cyber physics.
Ah, okay.
I don't know if you've seen the presentation, but I did some research in that, and there's some ideas about how I come up with that. Reading a lot of papers, if you can bypass zero trust,
Yeah,
you can
yeah,
go you on for like OT networks for SCADA
correct, correct.
using physics.
Yes, yes,
Go and attack the cyber IT infrastructure with physics. So
absolutely.
totally bypass all the money we spent on and
I do agree with you. If they are saying zero gap, if you don't trust, if you don't test, how you can say it's a zero gap? You have to test first, and
yeah.
then you can say it's a zero gap.
Uh, so there's some real scary research out there I've discovered that's recent. Uh, and so I pulled together
Wow,
a presentation on coming in over using physics to make actuators and sensors do things that we expected to come in over a network or serial connection, but you can actually come in and do things over physics
nice, nice.
so that's pretty interesting presentation I come up with and another one on some network stuff that everybody is still missing. Everyone, I keep laughing. I was like, everybody's worried about day zero, and we're missing year 40, year 50.
Correct.
It's like
Year 50.
we're missing the basics. Yeah. But everybody's worried about a day zero. Yeah. And,
Yes. And even back to 2018 in Hack in Paris, I delivered not talk, training as well. I delivered training on the industrial control system, that is OT part. And we were talking about how we can, attack, or rather, we can say attack vectors on the launch pad. So generally, Launchpad and everything, it's nothing but OT actually. All PLCs, all you know, the IDs and all those things works over there. And that was crazy because some people already came over there to attend my trainings from uh, space agencies actually, who generally works on Launchpad actually, rocket Launchpad. Then we discussed a lot of those aspects actually that time.
yeah, there's a there's a gentleman named Dr. Greg Falco, and he did a good paper on the launchpad
Wow,
threats. That's the only paper I know I've seen on the launchpad threats that you might find. He did a really good paper on that. But
correct.
yeah, but where he looked at the launch facilities,
Mm, that's nice. That's nice.
and this presentation I have focuses more on the rocket itself, the propulsion and
That's
stuff.
nice.
Uh,
Yes,
yeah.
yes. That's nice. So I think so. People are getting coming actually. So meanwhile, we'll start the you know the presentation. Before that, I would like to introduce from everyone. So hi guys, I am Arun Mane. I am founder of CyberX Village. Generally, CyberX Village is focus on very niche filled uh, uh, talks, research, hacking, these aspects. This is a open community where a lot of people comes from other backgrounds. Uh, the motivation behind this community is to introduce those niche filled hacking or research or any cybersecurity aspect to the world actually. And today is the second meetup online. What we are doing online. In future, it will have some in-premise talk as well. Uh, Today we have the gentleman name is Paul Coggin. Is a very close friend of mine. We met a lot of conferences, and we shared the same interest on space technology, rocket, avionics, satellites, a lot of things, and how we can go ahead. And even I learned a lot from him. Actually, he shared a lot of documents. We shared and each other, and I always take inputs from him because he's kind of very focused person, I would say, in this area actually. And he's not only covering the hardware related or any kind of system or rocket system, but also he's prominent in networking as well. So he's considered to be a genius person in the cybersecurity. And I would say, uh, as per my understanding, he's one of the best person in the world to talk about the very interesting aspect, cybersecurity in uh, space technology. So thank you so much, Paul, and I'm really happy you are here, and you give us a time, you from your busy schedule, and please, over to you, and wish you all the best. Yeah.
Yeah. Yeah, thank you for the very kind introduction. I will share my slides here, my screen, and let me get this playing. Do you see the presentation okay?
No, I
You
think so.
don't?
I can see my face.
Yeah, I told it to share my screen. Yeah, let's see. Okay, do you see me now? It says
Mm,
I'm sharing my screen. Do you see my screen?
no, I can see only your this thing, the uh Zoom Zoom panel. Yeah.
Huh. Well, okay, I'm not understanding why. Are you sharing your screen at the same time? I'm sharing.
I think so. You have to see. I think so. When you share, it will ask for sharing some screen. Go to the screen, I believe so. If you see the screen, so it will screen. Do you have two screens or only from the laptop, or you have other screen as well?
No, I'll just have the one.
Mm,
I'm sharing my whole screen.
yeah.
I'm not sure why it's not sharing with you. This works all the time. This is Guess we should have tested before we started.
I think so. Your screen is sharing, I believe so, but it's not looking at the. I think so. You have to go to the presentation PPT,
Yeah,
and then is it PPT on PowerPoint or on the web
yeah,
browser?
yeah, yeah. I've got it going. Do you see it?
No, you just click on the share
Yeah,
and go to.
let me try it again. Yeah.
When you click on the share, you will see the entire screen. You can click on the screen number one, so it will share your
Yeah,
entire screen itself, and
yeah,
then you
I'm having problems with this. I don't know why it's not sharing. Let me counsel and come back in, I guess.
yeah, sure, sure. Paul, you can re-log in again. Am I audible, Paul?
So do you see now?
Yes, yes, I can see now.
Okay. Okay. I don't know
Yeah,
what the problem was there. I'm sorry. I apologize.
no, no worries.
Uh,
Yes.
1:30 in the morning is what I'm gonna blame it on. Yeah. All right.
Over
So
to you.
okay. So I'm Paul Coggin from the U.S. I apologize for the issue getting started there. Uh, this presentation, we're going to talk about rocket propulsion and issues to be considered from a cybersecurity standpoint with rockets. Uh, got I got my interest years ago for cybersecurity in well, actually with rocket scientists. I started watching cartoons like a lot of kids in the U.S. But we have some what they call Looney Tune cartoons that would always have things about rockets. Got me curious. I had a math tutor that actually worked on the Sputnik rocket when I was going through my math classes during working on my bachelor's in math many years ago. And my math professor, and they got me very interested in rockets and things. And then a couple years ago, I finished a fourth master's degree in space systems, where I took a lot of classes on rockets and rocket propulsion, rocket launch facilities, and things. It got me really interested in rockets again, and I was thinking though, going through all that academic exercises, working on the degree in space systems, of how does cybersecurity apply to a rocket? Because I'm a cybersecurity person. I was like, I'm taking all this punishing courses. How can I tie cybersecurity into this? Is there uh, some commonality there? And I started digging into it and found that there actually really was. And so that's what this presentation is going to be about. So when we talk about space systems, in start looking at cybersecurity, there's a lot of conversation about space segment. The RF communications, optical, laser communications, the user segment, where you got the end users uh, into the connection. Uh, the you got the your link segment and the ground segment. And what we're going to talk about in this presentation is we're going to go over in the ground segment in the on the right, in the bottom right hand corner of that picture. You see the launch facility and the pre-launch. Well, we're going to focus on the rocket itself, the rocket propulsion. Like I was mentioning earlier to Aaron that Dr. Greg Falco has a really good paper on launch facilities. But this presentation, we're going to focus more on the propulsion side of a rocket, uh, of how cybersecurity can influence the rocket possibly. And so when I started digging into this, I started thinking, well, what is the possible attack surface of a rocket? When I was doing the academic exercise, like, what all the components and what all is there besides a whole lot of fuel? And but it turns out there is a significant number of computers on a rocket. You have sensors, actuators. Kind of think of when I say actuators, think of like PLCs. Uh, There there's lots and lots of different sensors, embedded computer systems, like, you have, camera sensors, you have the flight control computers, you have the command, telemetry, and control, navigation, you have the, radio communications, embedded systems so that the rocket can talk to the ground system. You have the network inside of the rocket because you have all the sensors that can go and communicate to the main onboard computer for the rocket. So uh, there is a lot of embedded systems, embedded computer systems on these rockets. It turns out. Now, what we're going to specific look at one area we're going to spend a lot of time focused on is over here on the right in a rocket propulsion system is the engine control system. Because your engine, it's not like, they show on cartoons and things where you just light the rocket up and it just burns. All the, that happens with solid rocket engines where the fuel is solid, and but now more and more there's new technologies even where with solid rocket fuel, they can control that now. It's not just a continuous burn. Even the solid rockets can be those booster rockets can be the fuel can be controlled just like a liquid uh, rocket can be controlled. But so we're going to look at this engine control system and how that might be influenced. And as we talk about rockets, I found some interesting data that on the SpaceX rockets, the Falcon 9s, for example, they're using Linux operating systems. Uh, it used to be with different spacecraft with satellites and rockets, there was a very diverse group of operating systems. A lot of proprietary operating systems, a lot of proprietary languages might be used. Uh, but now things, just like a lot of what we see across the IT industry in general, everything is converging on Linux and open standards for space systems, just like we do in, say, manufacturing environments now. Uh, and so on the SpaceX rockets, they're using Linux. So I found that very interesting. Now, when we talk about rockets, but if you watch YouTube videos, watch the news, you see rockets, and sometimes rockets malfunction, and they have to destroy the rocket because there is some anomaly that happens during the initial launch of the rocket, uh, and the ground control system may send a signal to explode that rocket. Well, that happens with something called a flight termination system, and in there with the flight termination system, the ground station can send commands and send it to this flight termination system and tell the rocket to self-destruct and explode strategically over a safe area so that it doesn't, harm anyone if it starts going off course. And historically, originally, those flight termination systems may have not been using encryption. It could have been using open communications, and then the earlier systems, of course, would be considered to be using weaker encryption, legacy encryption that we, now with computers as fast as they are, can quickly crack some of the old legacy encryption. But the more modern flight termination systems, the automated flight safety systems, they're using AES encryption on the newer flight termination system, so they can be more secure than the historical flight termination systems. And so that jumped out at me as if a rocket was using the more historical no encryption or very weak encryption, that could be a an attack surface for the rocket. Now, when we start getting before we dive really deep into rocket science, I wanted to go and lay a foundation of where this all started with rockets. Originally, it's based on Isaac Newton's three laws of motion, and then there's a gentleman named William Moore. He was a British mathematician. Back in the early 1800s, he published three papers on rockets, and I went through a whole master's degree, a whole graduate degree on space systems and a lot of courses on rockets. And William Moore was never mentioned. So I wanted to give William Moore a shout out and acknowledge his initial work. But because mostly what you study academically is this Konstantin Tsiolkovsky, this Russian rocket scientist, and what we call the ideal rocket equation that we're going to get into and look at of how a cybersecurity professional might be able to figure out how the variables of the ideal rocket equation could be influenced. But there's a number of gentlemen that that are known for being key contributors for to rocket scientists besides Newton and William Moore, the French gentleman Peltery, Robert Goddard in the U.S., Oberth in Germany, and stuff. But like, well, we're going to focus on this ideal rocket equation from the Russian gentleman Konstantin Chovalsky. Uh, uh, but since we mentioned Newton, what we're pointing back to with Newton is the three laws of motion. We get it. A lot of the initial rocket science, the foundation goes back to real simple force equal mass times acceleration that we all learn in school, and it's very basic algebra, but for the very initial algebraic formula that we become familiar with when we start studying algebra and start studying basic physics of the force equal mass times acceleration. Then when we start talking about rockets, it's going to be that mass and acceleration is going to be that initial mass of the rocket when the rocket is loaded with fuel. And as the rocket takes off and gets launched over time, it's going to gain acceleration, it's going to gain velocity over a period of time. And so that's what we're showing there with the formula with force equals the initial mass with the initial velocity minus well, spread over time as that rocket launches. It's going, you're going to lower your mass is going to decrease, your velocity is going to increase uh, as the rocket burns, and so your force variable is going to change over time. But so, but that is foundational to what we're about to get into, and we're going to look at how these different variables involved with physics of rockets. How can we influence those as how can a hacker possibly influence those variables to impact the performance of the rocket? So I mentioned the Russian gentleman Tchaikovsky's ideal rocket equation here. And so here's some of these variables that we're going to. There's in this formula what we're looking at is delta V. And delta V, down there at the bottom, that delta V formula, what that is alluding to, delta V is the how much velocity is going to be required to get that rocket into orbit that we desire. Is it going to be an Earth orbit, or we're going to go and put the rocket into orbit around the moon, or are we going to need enough delta V to go to Mars, to go to Juniper or Pluto or what have you? What is the mission of this rocket? How far is it going to have to go into space? And depending what kind of orbit we need is going to determine how much delta V we're going to need, and that delta V is going to be the change in velocity. So we're going to have to have enough fuel to get that rocket into the orbit we need. Uh, and this is how it is calculated. And then from a cyber standpoint, we're going to look at these variables and what is the attack surface that we need to be aware of to protect that rocket as cybersecurity professionals. If we find ourselves working in the space industry, what all do we need to look at to make sure that we're protecting that rocket? All the sensors and the actuators from the supply chain all the way through operations. What do we need to consider? And so we're going to look at these variables and how they might be influenced. Now go back to delta V. We're going to explain this delta V equation real simply. So, so the first step, you see step one there in green. That's going to be when the rocket initially launches, and you get the rocket up into the initial Earth orbit, for example. And we had enough delta V. We launched that rocket. We had enough fuel. We gained enough velocity to get this rocket up into, say, an Earth orbit, and that would be one. We had enough delta V to get enough velocity to get into orbit, to that initial orbit. But now we've got our goal is to go to step three, where we go on to, say, Mars, for example. So we're going, once we're in that orbit, we're going to send, the rocket is going to initiate another delta V, where it's going to burn more fuel to get on to to the second step of the orbit. And then followed by that, it's going to ignite the engines, burn more fuel the third time to go on to the final orbit. Say, like we mentioned earlier, maybe Mars, could be to go orbit the moon, or etc. So every time we go and give more fuel to that rocket, we send that signal to burn more fuel. That's burning more delta V, and so we got the mass of that rocket is, each time we burn more delta V, we're burning more fuel, and that fuel mass is being burned up. And and so what are some possible attack scenarios against a rocket propulsion? So from maybe when the rocket is on the ground, maybe there's software vulnerabilities, maybe in that launch facility, maybe there's authentication bypass vulnerabilities, or somebody got in the supply chain somewhere and messed with the algorithms, and like that delta V calculation. Maybe they go and mess with the variables for the mass, and make the rocket think that it has more fuel than it does, so that it's not able to actually get on to the orbit that it's supposed to go to, or the communications, the say the GPS. It could possibly mess with the position, navigation, and timing, or the avionics, being able to send commands to the rocket to tell the rocket to launch its payload, the satellite payloads that are on it. Someone could try to jam and spoof the rocket communications. With software-defined radios, if somebody's got a powerful enough antenna, and with software-defined radios, if you're not using strong encryption, could someone do spoofing, for example, or they got enough power with a jammer to try to interfere with the signal, or maybe they look at sensors. You would have many, many, many sensors on the rocket that could be targeted from the supply chain all the way through operations. Say, like temperature sensors, fuel sensors, different safety sensors, pressure sensors. We're going to talk about pressure in more detail in a couple slides. The engine control unit, somebody could maybe mess with the embedded engine control system, and influence the operation of the thrust, uh, mess with the fuel consumption, and how the fuel and oxidizers are being mixed. We'll look at that further. Possibly the supply chain for the fuel. In Dr. Greg Falco's paper, looking at rocket launch facilities, he talks about fuel could be the fuel sources that are coming into the launch facility could be targeted, and you could have again, hardware and software, firmware from the supply chain all the way through, depending on the level of access an adversary may have. It could be a trusted insider that is for maybe even possibly terrorist, etc. You don't know what somebody's loyalties could be. They could be a sketchy person, and they got access, and they maybe change your firmware on a sensor, or some vendors put in a remote backdoor, maybe a 4G, 5G remote radio access into the launch facility, so they can try to get in and influence the launch, and maybe try to trigger the flight termination system through a remote backdoor. Who knows? But all these things, as cybersecurity professionals, and if we're involved with the space industry, we need to go and account for this attack surface, just like we would if we were in an enterprise trying to protect, say, an Active Directory network. Uh, so let's look at this delta V equation. So in the variables in the delta V. So you got that M, where you say that MI and MF, you're looking at the initial mass of the rocket and the final mass of the rocket, where in the final mass, where the fuel's been burned off, but and the flow rate of that rocket, how it's burning fuel as it launches and is uh, going through its mission. So some an adversary through the supply chain, or if they got access into the ground station, or if it was using weak encryption, could possibly influence that rocket to modify the mass flow rate, the fueling process, mess with the different sensors so that the rocket changes how it's burning fuel. Uh, that could alter the delta V so that you don't have enough velocity to get that rocket into the proper orbit. Uh, Maybe they manipulate the fuel mixtures, the timing of the fuel mixtures, like we mentioned, possibly going after someone could go after the guidance, navigation, and control systems. Uh, either jamming or spoofing, or and if they started, or maybe if they say if they were able, if you were not using encryption, if you didn't have strong encryption on your communications, your GPS, if your communications are not secure and someone's able to tell the rocket that it's one place when it's actually another, you could get the rocket to get off course and make it burn more fuel to actually get into the correct orbit. And if you're burning more fuel than you have available to conduct your mission, maybe they make your mission unsuccessful because they caused you to waste fuel. Now, we mentioned that force equal mass times acceleration. Well, that actually goes maps to the thrust equation, where force equal mass times the velocity, the exhaust velocity, and that can also we can break that down further and and utilize the variables for for pressure and the area inside the exhaust, and as we show here at the very top. And so you could, if an adversary got into some of the like the pressure sensors, they could modify it, influence how the thrust is operating, how efficient and accurately the thrust calculations are working on the onboard computers, because maybe the adversary messes with the sensors inside the engine exhaust or the ambient pressure sensor, and the ambient pressure sensor is looking at the pressure outside of your exhaust, your engine nozzles. Uh, and when they start messing with those variables, that could influence your delta V. And if, like I said, then what that adversary is going to do is going to make that rocket not operate efficiently as it was originally designed. If they can somewhere in that whole engineering life cycle, the mission life cycle of that rocket, from the initial supply chain through the fueling, through the different sensors and computers, can they influence any of those variables to make that rocket not perform as desired? Now, I like to go when I look at cybersecurity, I like to use attack trees. I think if you're doing red teaming, purple teaming, I think it's just good to go and break things down into like a flow chart, and we call them attack trees. When I first got into computer science, we called my very first classes, we called it flow charting, breaking the problem down step by step. And I think this is a good thing to do, or a good practice in cybersecurity, from a red team, pen test team, blue team, purple team, to go and break down these problems step by step and make sure that the team really understands what we're dealing with, and we're thinking through all the different avenues, all the different attack surfaces and steps that an adversary may look at our system from. And so, like one in this example, going after the rocket propulsion system, maybe someone goes after the onboard control system. They want to manipulate the thrust during ascent here, and maybe they try to that ISP variable is the specific impulse, and what that ISP variable is, that is how efficient the rocket is burning fuel. And then you got the VE, the exhaust velocity, and those figure, and so that could influence your thrust. Maybe they go after the exhaust pressure, the ambient pressure, and one of those variables, and try to influence that rocket and disrupt the mission. And all of those and all of that those variables map to different sensors. It's going to map to actuators that are going to control how the fuel's being mixed. Uh, and the all of those different sensors basically are the computers that have firmware and software. And that and if an adversary anywhere in your that whole engineering life mission engineering life cycle could influence how that rocket's going to perform. But I think as cyber professionals, I think it's due diligence and good security systems engineering to do attack trees to plan this out and look at this in detail up front and think through all the steps. Uh, and here's another attack tree example of like the flight termination system. If maybe some an insider, compromised insider, a vendor, a supplier, uh, possibly on the ground or remotely. Maybe someone's got a back door because they had access, physical access to the facility. Maybe they put in a remote radio. It's like a 4G, 5G, or a Zigbee, remote Zigbee radio type connection into the ground station, so that they could get some kind of RF, remote RF communication into the ground station, or they're there locally, or some other kind of backdoor, so that they can influence that flight termination system and communicate with that rocket in band. Because if they're mostly, today, most likely they're going to be using good encryption, hopefully today. So they're going to come up and maybe develop an attack tree themselves of how they're going to get into that system and be able to go after that flight termination system and be able to send commands to the rocket to make it detonate and explode before it's able to conduct its mission and get up into orbit. But I think this is really, really important in the initial security systems engineering. When a lot of folks today, a hot buzzword is digital engineering, model-based systems engineering, and when all of that initial systems engineering process is happening, I think it's really important to go and look at all of these different attack surfaces with and make sure this is accounted for when we're designing the system. Not only look at how the system is going to function from operations, but also cybersecurity. Uh, Make sure that rocket is going to be secure, and somebody's not going to try to help us out and get our mission uh, to not be successful. Um, Now, zero trust, the concept of zero trust is very popular today in the IT cyber community. And so I started thinking as I was looking, researching rockets in school is how could zero trust possibly apply to rockets? Well, how these rockets, especially the larger rockets, they will have possibly three computers in what they call an actor judge architecture. So you have three computers, and they're in this actor judge architecture. And what that means is those three computers have to agree with each other. And if they don't agree, whatever the calculation is that they don't agree on, they throw it out and recalculate. And so you have those three main computers in some cases, especially like I said, these larger rockets. Um, and then those computers are going to control numerous sensors and actuators that are going to kind of like PLCs that are going to make changes and turn on different fueling systems and control the amount of fuel and oxidizer that are being burnt using your actuators. And then, of course, you're going to have all your sensors, your time and temperature and pressure, lots of different pressure sensors. How efficient is the fuel burning? All those in those computers. So that there's going to be a trust relationship. There's going to be a trust relationship between all those embedded system sensors and actuators to the main onboard computers, and all of those communications need to be secure in case something goes is being influenced. You want those trust relationships uh, secured and locked down, and maybe possibly encrypted, going back and authenticated to know that that only the systems that need to be talking are actually talking during the launch, and also locking down the trust relationship, applying zero trust and locking down the communications to the payload on the rocket. You don't need satellites. If you have a large load of satellites on the rocket, you don't need a satellite from one vendor talking to the satellite of another supplier, for example. You want to lock down that communication on that bus between the different spacecraft that you may be carrying up into space on that rocket. And so that got me thinking about that. I was reading that there's a new technology, a recent technology called time triggered Ethernet. If you're not familiar with it, uh, and what happens with time triggered Ethernet? If you're familiar with telecommunications, in the US, we use T1, T3, Sonnet, the legacy time division multiplexing protocols. In other parts of the world, y'all may use E1, may have used E3, SDH, and that is time division multiplexing technologies where time slots are guaranteed using that time division multiplexing technology. Well, it turns out that some technologists have figured out how to take time division multiplexing uh, and overlay that into Ethernet so that you can have the benefits of time division multiplexing where you got guaranteed time, guaranteed bandwidth resources, and apply that to Ethernet. And so that is being actually used now on spacecraft. NASA's used it for a spacecraft. So since that time triggered Ethernet is being implemented in new, more modern spacecraft, that got me thinking, hey, if they're gonna go and start using time triggered Ethernet and moving away from some of the legacy bus technologies, if we're going to use Ethernet, then we could use software defined networking. If we can do software defined networking, we can start doing from the zero trust. We could do micro segmentation, and we can use micro segmentation to granularly lock down the trust relationships between those onboard computers that are controlling all the sensors and actuators, and granularly control those trust relationships and lock that down and apply encryption and authentication, just like we can in other networks. So those are my thoughts on zero trust. I haven't not found a lot of research where anyone has implemented on a rocket yet, but this is some of my initial thoughts on where things could evolve with being able to do zero trust on a rocket over time. And if you're involved with the space rocket industry at some point, this is something to consider because the technologies are rapidly evolving for this. And so it is. So I was doing this research. I was like, okay, think I've got some ideas of how physics can be influenced by a hacker, and us blue teamers. We need to be able to go and defend these physics-based sensors and actuators against the bad guys. But then that's like, okay, are there any real world examples? Is anything out there happen with rockets? In space, because there's a great deal of public that's been published about satellites and ground stations. Tons of information about ground stations. There's been a lot published about cyber attacks against astronomy sites. There's a lot published around uh, satellites being attacked, jamming, spoofing, satellites being hijacked. Um, but I was like, so, but what about rockets? You never hear much about rockets. So started digging into that, and I actually found a few examples. So it turns out I was reading this book, The Perfect Weapon, and in the book, The Perfect Weapon, this David E. Sanger, he references an occurrence where a North Korean missile was disabled in 2012 using a cyber attack. So uh, there's one example where North Koreans their missile program was affected by cyber. A second reference I found from a reference from 2022 is there was an Iranian missile system that was apparently disabled by a cyber attack uh, many years ago. And then there's speculation. I found on found some references. It's not been determined that this is exactly what happened, but there's speculation that I was able to find regarding two Russian rockets. There was a Russian a Proton rocket and the Zenit rocket, and they both had missions to Mars. And remember our conversation we were having about Delta V, about getting the rocket launched and the initial Delta V and having enough velocity to get the rocket to low Earth orbit and then give the rocket more delta V, more fuel, more velocity to go to the different steps of the Holman transfer to get the rocket on to its final orbit. And in this case, the final orbit would have been Mars. Well, the rocket was able to have enough delta V to get into Earth orbit. But once it got into the Earth orbit, something malfunctioned that there was not it could not get delta V, could not get more fuel and continue on its mission. It couldn't get enough fuel to keep the velocity and get the velocity increased to go on to its next orbit goals and that trajectory on to Mars. So, and there's speculation there that it could have been security related because apparently it was known, according to what was published online, there was speculation that it was known that the rockets may have not had the best security. And so I found that interesting, but there's nothing concrete that says that they were actually hacked and things, but there's a lot of speculation around it. So that's what I've been able to find about rockets. Not a great deal published about rockets like there has been satellites and ground stations and astronomy sites. But but those are some examples I found for conversation and to show that we at least need to do due diligence as cybersecurity professionals and protect these rockets and and protect the sensors and actuators and the computers that are going to be a part of that rocket system. Now, some resources to go look at if you're not familiar with space cybersecurity. Uh, there's an organization called Aerospace Corporation. If you probably have heard of Modern Attack. Well, similar to Modern Attack, Aerospace Corporation came up with a security framework called Sparta, and it's very similar to Modern Attack. And so you need to be aware of this if you're starting to look at satellite security, rocket security, if you're getting involved with the aerospace industry. Uh, uh, And similar to Sparta, the European Space Agency has come up with the SHIELD framework. Again, this is very similar to Modern Attack, but focused on space. And this is, and so here you need to want to be aware of the European Space Agency SHIELD framework that you could utilize for securing your space systems, your rockets, your satellites, etc. And there is a you're probably familiar with the ITU and IEEE that create a lot of the standards that we use for computers and networking, telecommunications. Well, also similar to the ITU and IEEE, there is a group called the Consultative Committee for Space Data Systems. And they publish a document. They publish a great deal of documents, actually, standards, tons of standards, how everyone agrees that systems are going to work, how components are going to work, so that it's cheaper and easier to integrate components from the various suppliers. Well, this organization also published a great deal of information on security and how encryption should be implemented, for interoperability and proper security, et cetera. And they have this one document here that I really like as a cybersecurity professional. If you're interested in this domain, I highly recommend you go and find this document on cybersecurity threats against space missions. This is a fascinating document, and this is an international organization, collaboration between uh, experts from around the world, lots of different organizations, lots of countries involved that have contributed to this document, and they go through many scenarios for space systems that need to be considered for cybersecurity. So if you're interested in this domain, you find yourself working in the aerospace space domain, you really need to know about this document because it can really help you and your team make sure that you're considering everything when you're doing your systems engineering and you're out there doing testing and developing your red team plans, your purple team plans and strategies, your blue team plans for how to do ongoing monitoring, etc. Really, really good document. I highly recommend. Uh, that's what I have for you. I hope this was of interest to you and of value to you. I'm going to provide Aaron with the slides, and in the slides I have many, many pages of detailed source references so that you can go and find the articles and papers that I used to do this research and come up with these slides. Uh, if you're interested, like I said, I'll provide this day run so you can go and dig deeper into the different topics and continue your own research into this fascinating domain. But this is what I have for you. I appreciate everyone that attended. I hope it was worth your time and that you learned something. And from it, I know I learned a lot doing the research on it myself, and I appreciate being invited to speak to y'all today. Thank you.
Thank you, Paul. Uh, Thank you so much, actually, for your valuable time. Uh, Guys, any questions? Let me know on the chat. But I have one question from my side. Like SpaceX, they use, uh, you know, the vector propulsion engine, specifically Merlin and Raptor. They use for, Falcon engines, actually Falcon Heavy or Falcon 9. So, is there any you come across any kind of glitch related to the cybersecurity attack in the onboard onboard computer, or someone change direction, because these engines are used to use for to land automatically from space to landing area, right? So have you gone, or have you saw any kind of attack in this case?
No, I haven't. There's nothing published that I'm aware of, and they're very, very intelligent engineers, and they have their own Linux kernels, and they have, my understanding is they have a team that specializes in analyzing their operating system and software for security. They're very, very they do a great deal of due diligence in analyzing their code and securing the system. But I'm not aware of any kind of anything security related with SpaceX outside of that they have a great deal of expertise working on it to make sure that they don't have any issues. They spend a great deal of money. They spend a lot of resources making sure that their stuff is
Correct,
operates.
correct.
They
Absolutely. So,
uh, they 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 do. Nobody's perfect, but they're very diligent according to everything I see published. They're very intelligent and very diligent in their very strict engineering processes. Uh, they're very
absolutely.
impressive. But I don't know of anything I haven't seen, or if we anything ever happened, we would all probably know about it and see it in the news and things. But I'm personally not aware of anything outside of that. They have very strict engineering processes. One thing that I will point back to, I was mentioning the security system engineering. There's a gentleman named Ron Ross who used to work,
Hmm.
who previously worked for NIST until recently. And if you go look up Ron Ross on LinkedIn, Ron
Hmm.
recently published a really good paper about space systems and security engineering versus doing the classical compliance-based security, and in contrasted basically doing compliance-based security versus doing good security systems engineering up front using NIST 160, the NIST 160 standards for resiliency. Uh,
Correct.
using leveraging NIST 160 up front in your initial security systems engineering to really lock the spacecraft down and to secure it. And they point to a project that NASA had where they took two digital
Correct.
twins of a satellite, and they gave the compliance, the team that was going to secure the system and test it based on compliance, and had the red team, blue team work on one digital twin, and then they had a second digital twin of the satellite, and they had a team go in and secure the system based on NIST 160, where the system was locked down securely in the initial systems engineering design through that process all the way through, and and then had the red team go and hack the system. And apparently, it was reading that paper, there was very significant differences in the security performance that going and using the NIST 160 process in the initial security systems engineering showed huge differences in detection and prevention and being able to lock the system down. So I would recommend, if you're getting into this industry or any of the critical infrastructure industry, the OT, SCADA, check out the NIST 160 standards because it looks,
Awesome.
according to Ron's paper, it makes a huge difference, and could really help out with the space industry uh, efforts.
Awesome. 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 Uh, yeah. So, I think so. The question we there is one question: how does modern technology like cryptography, AI, and machine learning to use to space industry?
Yeah, I what I think is going to happen is you're going to see satellites be operated autonomously, and from well, obviously we're all interested in cybersecurity. I could see AI being used for satellites to automatically defend themselves and maintain orbit, make orbit changes, dodge debris in orbit. If you haven't ever studied it, go look in Kessler syndrome. There's something called Kessler syndrome where there's a great deal of fear about debris, maybe a piece of debris in space hitting another
Hmm.
spacecraft or another piece of debris, and it causes a chain reaction where eventually there's
Yes.
debris creating debris that creates so much debris that space becomes unusable in low Earth orbit. And I could see AI being used on spacecraft to autonomously dodge debris, and maybe doing it today, and I'm just not uh, involved with that. But I could also see not only AI being used for avoiding debris automatically, but also uh, from a self-defending satellite or self-defending spacecraft standpoint, that the spacecraft could autonomously, if it detects electronic warfare, jamming, spoofing, or some kind of nefarious cyber attack against it, some commands being sent out of order, uh, commands, some issue with commands that may appear to be sketchy. Uh, whatever kind of behavior the spacecraft has detected as suspicious. I can see AI being used for the satellite to change RF frequencies, say from jamming and spoofing attempts, where I can see it defending itself automatically against like electronic warfare or any kind of cyber attack, just like systems can here on the ground. I did actually did a presentation. If you're interested in that, go check out. I have a presentation. It's out on YouTube uh, on space cyber immunity. I did a couple years
Great.
ago, and I got into this about how a spacecraft could defend itself. And so that's where I see AI going. So go check out Space Cyber Immunity. I did a whole presentation uh, on how the spacecraft might be able to use AI to detect issues and defend itself. And I think I believe if it's not already being used, I believe that's going to be something that's implemented in the future because the technology exists in enterprises today. Cisco back in the early 2000s came up with the concept of self-defending networks. Where routers and switches and firewalls could be dynamically reconfigured uh, based on anomaly detection, behavioral detection from intrusion prevention systems, that whole intrusion prevention system technology. So basically, it's been in place it's existed in enterprises for over 20 years now. So it makes absolute sense, especially with today's AI algorithms, the AI technologies we have, that we could see that implemented in satellites. So go check out my presentation on space cyber immunity. And
Awesome. Awesome. So that's great. So definitely we'll share about the details, your presentations as well. Guys, do let me ping us. We'll send you the link or we'll upload it on the our CyberX website. Do check over there. Up to 2 or 3 days, we'll upload everything over there itself. And as we know that these are the recording sessions, so we'll upload over there as well. Thank you so much, Paul, for your wonderful presentation, the knowledge about the rocket. It's literally rocket science, I'm telling you. Everybody says, everybody says this subject is not a rocket science, but you are teaching a rocket science actually. So that's the best thing I ever seen actually. So
uh,
thank you so much.